Meshes can be transformed in the 3D space using position, rotation, and scale properties. Let's discover how it works. In a 3D space, there are three axes. The X, which points from the left to the right, the Y, that points up, and the Z, that points toward us. So if you go minus Z, you go forward. Be careful that X, Y, and Z can change between different software. For example, Blender and Unity have different axes, but it's never a big deal to convert from one axis system to another. To represent points in a 3D space, Three.js used the vector3 class. It's made of three numbers for the three axes, X, Y, and Z. To create a new vector3, you say new 3.vector3 and the X, Y, and Z values. Let's open our starter pack, run yarn, and yarn dev. We have a green cube in the middle of our screen. If we look at our code, we can see that we have three cubes, one red, one blue, and one green, but they are at the exact same position and we can only see the green one. Let's move the red one using the position prop. It takes a vector3, but thanks to React 3 Fiber, we don't have to declare a new vector3. We can pass an array with the value X, Y, and Z. So if we want the red to be on the left, we would say -3 on the x-axis. We will keep the blue one at the center, and we will put the green one on the right by setting the x position to 3. We save. Now we can see our three cubes independently. If instead of the x position, we move it to the y position, 0 and 3, so the second one is Y and the last one is Z. We have the green one on the top because Y is 3. This one is at 0, the blue one, and the red one is at -3, so we see it below. But instead of using position and an array, we can just say position dash the axis we want, so for example Z, and we can say -3. Here we can just keep the default because we don't touch it. The default position is vector 0. And here, position Z is equal to 3. Now you can see that the green one is closer to us because the Z vector is facing us and it has the highest value than the blue one and the red one. Let's put them back next to each other with -3 and 3, and let's play with the scale property. We can pass an array of x, y, z coordinate, 0.5, 0.5, 0.5. Here we keep it untouched, it is 1. And we can also do scale is equal to 2 if we want to change all of them at once. We have a small one, the one at 0.5, the normal one, and the one at 2. But by playing with the scale, we can create completely new shapes. We can say 1, 0.5, 0.5. This one we can say scale y is equal to 4, and this one scale z is equal to 3. Now each of them are completely different. Let's see how to rotate our meshes. As we did for the position and scale property, the rotation property takes a vector 3. But the main difference is that the values are in radians. And if you are like me, you are more used to angle in degrees than in radians. For example, a right angle in degrees is 90. I don't know the value in radians. But there are some ways to help us find the right values. The first one is to use 3.mathutils and use the deg2rad function. You pass the degree you want and it will return you the radian. When you use 3, never forget to do import star as 3 from 3. Then let's say 0 and 0. We can see that our red cube has been rotated of 45 degrees on the x-axis. But when you just need 45, 90 degrees, it's easier to use math.pi as a shortcut to 180 degrees. So for example, divided by 2, it will be 90 degrees, and divided by 4, it will be 45 degrees. The same that what we did previously. If we look at it, it's exactly the same. Let's practice a bit with our cube. Let's say 0, 3.mathutils of deg2rad of 30. Then for this one, rotation y, like the other, we can define only one axis of math.pi divided by 4. And for this one, let's combine rotation y is equal to math.pi divided by 4, and rotation z is equal to 3.mathutils.deg to rad and 30 degree. We get this. Of course, you need to practice to get used to the rotation system. Let's stick our cube next to each other. So -1, we remove everything else. Here it will be the default one and position x to 1, and we remove rotations. Now they look like one block. We can wrap them inside a group, and a group, it's like a container for multiple meshes or multiple groups too. Now that it is in a group, we can play with the position, the scale, and the rotation as if it was one single entity. Let's put -2, -2, 0, put the scale to 2 to make it bigger. So we can just do scale is equal 2. Let's change only rotation y, and let's say math.pi divided by 4. See how we moved, scaled, and rotate these 3 cubes as one single entity.